With all of our gamma ray, both LWD and offset, imported, along with our mud logging data, we're now in a position to where we need to start importing the actual surveys from the well. On the spreadsheet in front of you is a typical set of data coming in from a service company providing the gamma ray and LWD service actually on the well. We have the standard information across the top. We also have the survey depth, inclination, and azimuth as seen here in columns C, D, and E as on this spreadsheet. Then we have the rest of the information, TVD, vertical section, the coordinates, the closure, dogleg severity, build rate, and so on that are provided by the service company. What we need specifically is the survey depth, the inclination, and the azimuth. We're going to import this data directly into the software using the same process that we used for the type log and gamma ray data. That application requires the first column to be depth, the second column to be inclination, and the third column to be azimuth for all survey data. So let's go ahead and just copy this information directly out of this spreadsheet. I'm copying the survey, inclination, and azimuth for what data we have here present. Scrolling down to the bottom, doing a Control-C to copy it. Go to File, New. We'll create a brand new worksheet and paste in our depth, inclination, and azimuth. Now, it's very important to remember that in order to get accurate calculations, you have to have the tie point correctly. Your tie point has to be exactly the same as the tie point of the service company. In this case, the tie point is 0 measured depth, 0 inclination, and 0 azimuth. Believe me, it won't always be this way. If they start logging the well at 4,000 feet, then you need to create the tie point where they tied into the well. Otherwise, your calculations will not match. And it's important that the geosteering survey calculations match almost exactly with those of the service company. So here we have our data in front of us. We'll go back into our software, go to the well setup, go find our well again. It's a John Brown number 1, return, and we'll go to survey data. And here we have the survey screen. Let's move things around so we can see everything quite well. The first thing I want to point out is on the very top of the screen, you'll see the tie point TVD, the measured depth at tie point, the northing and the easting for that tie point value. Again, this information must match what the service company has. In this case, we just happen to be zeros, so we're fine. Like the type log and gamma ray import, we need to know the starting row, which is 1, and the ending row of our data is row 61. Input that. We'll click on the Read Multiple Records. The system reads the depth, inclination, and azimuth, and then calculates the course length, the TVD, the vertical section, the northing, the easting, the dogleg severity, the azimuth, the distance, and departure for all of the information. Now you can scroll all the way down to the bottom of the data, and let's go back now and compare our information with that from the service company. We'll simply close out of our 3 columns. We don't want to save it. And we'll open it up here so we can actually see what we're looking at. And I will bring my application to the front. Or I'll just lay it on top like this, and we can compare the values. Measured depth 8140, inclination 4035, azimuth 738. TVD is 8080, Course length is 96 feet. And we need to move things around so we can see what we're looking at here. I may have to shrink things down a little bit so we can actually get all of our data on the screen. Okay, that's a little bit better. Vertical section is 227.13. 230.65 is reasonable. The northing is 227.13. That's correct. The easting is a minus 55.19, and that is correct. Now remember, these are based on quadrants. As I'd explained in the operations manual, there are two quadrants that are always going to be negative and two quadrants that are going to be positive. So please refer to the operations manual to explain that for you. Again, we have the dogleg severity of a 7.4. We have a 7.4. They have 7.37. And looks like all of our data is matching up very nicely with theirs. That is the way that you import the data directly into the survey spreadsheet. Minimum curvature method for determining what the actual values are of the three-dimensional geometry. From this particular screen, you can go to the geosteering screen, and you can also go to the well planning screen, all of which we'll talk about later on. For now, we're just simply going to return, and we're back to the main geosteering menu. The next thing that we will begin talking about in the next video is geosteering itself. Thank you.